Hey guys, it's Miss Beckham. I wanted to provide a video for you guys over Unit 7, the Unit 7 test. So if you took the Unit 7 test and you did not pass it, or if you're about to take the Unit 7 test, then you should watch this video first. And if you're here for corrections, if I've referred you to this video, then you need to grab a piece of paper and actually write down the problems that I'm doing with you so that you can that's what I recommend to kind of process this information. But there are three math problems in the test, Unit 7 test. And consistently, I found that most students got those three problems wrong. Like almost every student who had a problem got those three wrong. And so we're going to do those exact three problems, except I'm going to change just like the chemicals. I'm literally going to change one part of it, but it's the exact same process. So if you're following my process, even if you don't fully understand things yourself, if you're following my process, you're going to get the answer right, and you're going to be so proud of yourself that you actually did this problem. And if you still have questions, please join my classroom or text me to get help with that. So we're going to start with this question here. It says, solve the problem, find the delta HR of the reaction. Delta H, that means the change in enthalpy. H means enthalpy and delta means change. Okay, it's asking you to find how the enthalpy changed. Do we have a positive change or a negative change? What happened here? And so the best formula for this to find the overall change in enthalpy of the reaction is to take the change in enthalpy of the products and add them up, and then subtract out the change in enthalpy of the reactants after you've added them up. Okay, so what that means is, remember, my products are on the right-hand side. These are my products right here, and these are my reactants right here. So let's plug this in and apply it to our problem. My products are the 2 times NaNO3 and the CO2 and the H2O. Those are my products. So I'm plugging that in right there. Okay, minus my reactants. So that's the Na2CO3 plus 2 times HNO3. Okay, so basically you sum up your products, put them in parentheses, subtract, and then sum up your reactants. And remember that if there is a number, a big number in front of your chemical, you need to multiply by that number. So 2 times NaNO3 or 2 times HNO3. So now I've plugged that in, but how do we find the delta H for these numbers? Well, you're going to go to your chemistry reference guide, and you're going to go to table B12, if I remember correctly. Yes, B12 on page 58 of your guide is where it starts. And we, remember, are looking for the delta H value. So when you look here, delta H is in this column right here. So we're going to find each of our chemicals and write it down exactly. And we're going to be specific. We're not going to cut any corners when we're writing these notes down, because it's easy to cut corners and write it down more quickly, and then you get it wrong. So we're going to plug it in exactly. So 2 times, and now I look up NaNO3. So that's sodium nitrate. So it'll be in the S section, sodium nitrate, NaNO3. The delta HF is negative 466.68. Negative 466.68. And I'm going to put that in parentheses, like a double parenthesis, so that I know the order of operations there. Plus CO2. I'm going to find carbon dioxide. Looks like it's negative 393.5. Negative 393.5. So I'm saying plus negative 393.5. That's the same thing as really saying minus 393.5. So plus negative 393.5 is the same as saying minus 393.5. You can write that whatever way you want, but I just want to be really careful when I'm writing it. Last one is water here. So the W's, negative 285.83. Negative 285.83 minus, and now I do the reactants, the Na2CO3, which is right here, 1130.77 plus 2 times the HNO3, the nitric acid. So HNO3, negative 207.36. Negative 207.36. I'm running out of space here. Okay, so now I just need to put this in a calculator I'm going to use the Desmos scientific calculator, and I'm going to plug it in real quick. So I plugged this into the Desmos calculator right here, and you can double check. Make sure that you're putting parentheses around anything that you're multiplying, and then I just put parentheses around everything just to be careful. And I got negative 67.2 as my answer. Negative 67.2 in kilojoules is the unit that goes with it. So remember that negative sign? That means that it's an exothermic reaction. Heat has flowed out from it into the environment. For it to be a negative sign, it's like a withdrawal in your bank account. So you're giving money to the environment, or giving heat in this case. The next question says, calculate the delta G of the following reaction and state whether it is spontaneous at standard temp or not. Now look, these are the same, this is the same equation, right? These are our reactants and these are our products, but this time it asks us to find the delta G, okay? So it's gonna be the same formula, except with G. Just like this, okay? And our products are the 2 times NaNO3 plus CO2 plus H2O minus Na2CO3 plus 2 times HNO3. So I'm just plugging in, these are my products right here, and these are my reactants right here. And now in my chemistry reference guide, I'm going to go back to the same chemicals, except I'm going to find the delta G instead. Okay, so let's start with the NaNO3, the sodium nitrate. NaNO3 right here, negative 365.89. Remember, you have to do the delta G value for it. So 2 times negative 365.89 plus, and now we need to do the carbon dioxide. Negative 394.36. Now the water. Negative 237.15. Minus, and now we need the sodium carbonate, the Na2CO3. So that's right here, negative 1048.08. And now the nitric acid. Nitric acid, negative 111.25. And now I just need to plug this into my scientific calculator again. When I plug all of that in, I'm getting negative 92.71. I'm going to scroll. If you're not getting the same answer, to make sure that you are putting this in the same way. And I'm using the Desmos scientific calculator for this, and I'm getting negative 92.71. So you can see how we're just taking the products, adding them up, subtracting the reactants, adding them up, and making sure you're multiplying by the big numbers here if they do have big numbers in front, okay? And then it asks to state whether it's spontaneous. The answer is yes, it is spontaneous because of the negative sign. So when the delta G has a negative sign, it means that the reaction is spontaneous. If the delta G does not have a negative sign, it means that the reaction is non-spontaneous. And last but not least, we have this problem here. It also is asking us here to find the delta HR. So you would think it's the same kind of equation we've done before, but if you notice, it doesn't give us an equation this time. So when you're conducting a calorimetry experiment, you're actually figuring it out for the first time without looking up a data table. And the equation you're going to use for this is called the specific heat equation. Q equals C times M times delta T. And Q represents the heat of the water. C represents the specific heat of the water. This is all in terms of the water. M represents the mass, and T represents the change in temperature, because delta always means change, that triangle there. So now we're just going to plug in our values and make sure we have the appropriate units. Heat should be in units of joules or kilojoules, but joules should be involved in our answer for our final answer there. So all the other units should cancel out. So the specific heat, it says the specific heat of water is 4.18. It gives it to us in the problem. So my specific heat is 4.18 joules per gram times Kelvin. It's a weird unit. See how I'm putting it in exactly the way it is here. So I'm just plugging that in. Now I need the mass of the water. Well, they gave me the volume of the water, so we could convert to grams using density, but thankfully the density of water is 1:1. So 500 mils is 500 grams of water. So I'm going to go ahead and plug that in, and you can see how my grams are canceling out right now as it is. Okay, and the last thing I need is the change in temperature. So it looked like the temperature changed from 25 to 43.6. So what is that change in temperature? It started at 25 and then it went to 43.6. So we could just subtract 43.6 minus 25 to get us the change in temperature. And I'm getting 18.6 degrees. And if you notice, the units for temperature are in Celsius, but we're going to want to convert that to something called Kelvin because the units here are in Kelvin. But thankfully, when you take the difference this way, it is the same thing. So it's also 18.6 Kelvin. So you don't need to do any magical conversion. It's just already, it can already be represented as Kelvin. So 18.6 Kelvin can go here. And then the K is going to slash out. And so now we just need to do 4.18 times 500 times 18.6. I'm getting 38,874, and the units that are left are joules, okay? Now, the answer wants us to represent it in kilojoules. So if you know, like, a kilometer is 1,000 meters, right? And a kilosecond is 1,000 seconds. So 1 kilojoule would be 1,000 joules, okay? So I just need to multiply and put what I want to get to on top and what I want to cancel out on bottom. And then I filled in the numerical relationship there. So see how my joules are going to cancel? So really, I'm just dividing by 1,000. So you take your answer, divide it by 1,000, and I'm getting 38.874 kilojoules. Last thing, this represents the heat of the water. The question asks us to find the heat of the chemicals reacting in the water. So if the water is getting warmer, if it has a positive change, not a negative, it's positive there, right? If it has a positive change, it's only because the reaction gave that amount. So you're going to flip the sign because we want to look at it from the perspective of the reaction. So it's going to be negative 38.874. So whatever answer you get, flip the sign because we want to look at it from the perspective of the opposite thing, not the water, but the reaction. Okay, or you can just tack on a negative sign at the very beginning if you want to flip the sign. So in summary, all that we did was we plugged in the specific heat, it's given to you in the problem. We plugged in the mass, it's the same as the volume here. And we subtracted the final temperature from the original temperature and plugged in that as our change in temperature. Multiplied them, divided by 1,000, and then flipped the sign. So it is like a lot of little steps, but it's not crazy difficult. It's just all of those little steps together. And that's how you answer this problem. So these are the 3 math problems that people have been getting wrong on this test. Try the test again or come back to my classroom if you have any follow-up questions or need my help with something, and I will be happy to help you from here. Have a great day.